Okay, this is section 13.1 on space curves, and this will be practice problems number 1 and 3. Both these questions ask the same thing. They want us to describe these curves, which in 3 dimensions can be kind of tricky. Number 1's not too bad. Because it is sine t cosine t, we know this will make a circle centered at the origin of radius 1. It'll actually be drawn starting on the y-axis and then going around in a counterclockwise direction until it reaches 2 pi when it will return to the y-axis. If you look straight down the z-axis, you'll see it as a circle. That's its projection. However, in the z-axis, it's cosine 8t, which means it will alternate between 1 and negative 1 as we draw the circle. So if you looked at it from the side, it's going to kind of look like a spring, it'll go back and forth with a cosine function, starting at 1 on the y-axis and alternating back and forth 8 times before it returns to the y-axis, having drawn the full circle. Okay, so that's sort of a visual of what this guy's going to look like. From the side, it'll look like a cosine that's being drawn in a circle with 8 full cycles. Okay, well, to see that, we could edit it right here. The text provides us with a Sage function plotter, but what I want to do is show you a more general one so you don't have to keep coming back to the textbook. If we go ahead and copy this code, then we can go to this website. This is actually what's embedded in the textbook. This is the Sage Math cell, and you find it at sagecell.sagemath.org. And what it does is it gives you a place where you can quickly and easily evaluate 10 lines of Sage Math code. There's the evaluate button. All we have to do is edit the function. So this one I have to flip sign for cosine. So this one's sine, and this one is cosine. And then finally, instead of t, this one's going to be cosine, open parentheses, 8 times t. And then I've got to go across and close the parentheses after. And there it is. So now we program that in correctly. This will plot t from 0 to 2 pi. That's basically where the range of the parameter is provided in the code. The rest of this we don't have to worry about right now. It basically controls what it's going to look like. It's going to put a box around it. It's going to, that's what plot 3D does. It's going to give it some perspective, and it'll plot the function in red. So let's evaluate. Okay, so there it is. And just as I promised, it is a full circle. Now, it's showing it in perspective here, which is why it doesn't all line up. But if we look at it from the side, we can see all of these functions are vertical, which means they do all lie within the same circle. And then you can see right here, if we look on the y, it starts at 1, and it basically goes through 1, 2 complete cycles in getting to pi over 2, and then it does the same thing all the way around, which is why it goes through this 8 times. If you count the peaks, there are 8 of them, and that's why it's 8t, right? So there it is. Okay, well, let's go back, and now what we want to gather is information about doing number 3. Number 3 is very different, t squared, and cosine t. Well, t squared itself would be pretty easy. We've plotted that many times before. That's just a parabola centered on the x-axis, wraps around the y-axis. Its vertex is at 0, 0. So it's basically an upward pointing parabola centered on the origin. The only difference is in the y direction, it's got this cosine t. So if we looked at it from the side, this parabola does not remain mapped within the xy plane. Instead, it starts out at 0, it's at 1. So it's above the xy plane. And then the whole parabola is going to sort of wave vertically. At pi over 2, it'll be within the xy plane. Then it'll plunge under the xy plane so that at pi, it's at negative 1. And then it'll just keep repeating that cycle. So when viewed straight down the z-axis, it'll look like a regular parabola. Except when we look at it from the side, it won't actually reside in the xy plane. It will wave above and below it. So anyway, let's go back to the website and plot this. So we'll go back here, and we want these now to be, the x component is t, the y component is t squared, which in Sage is t caret 2, and the z component is just cosine t, so I'll get rid of the 8 times. Okay, so there it is. Now I'll plot it straight away, and I'll show you that this range here isn't really best suited for viewing this, but we'll see that after we view it, okay? Okay, because the range is set to give us 0 to 2 pi, it basically doesn't do any negative numbers. And that's why what we see here is a half parabola. So there it is. Looking straight down the z-axis, we just see that it's a half parabola. This is the x-axis. So there we go. Again, there's the z coordinates there. If I turn it sideways, you can see what's happening in the z. See how it waves through a cosine function. This is a full function where it goes from its peak of 1 down to its -1. It goes through 0 in between and then back through 0 and back up again. The problem is it's only showing half. So I need some negative coordinates here, 2. So let me show you how to do that so I can see the whole thing. This goes from 0 to 2 pi. Let's go from -2 pi to 2 pi. So -2, and you can see it's 2 times pi will give me -2 pi. And then let's plot it again. And now you can see it's a little better. Now it's going to show us the whole parabola, the left side and the right side. So we can see it viewed down the y-axis or the z-axis. And then if we turn it sideways, there's the cosine, executing a full cycle. Okay, so there it is. It's a parabola that sort of has this wave going on in its third dimension. Getting familiar with visualizing these functions is really going to help you out in the long run. However, note that you always have the SAGE cell to help you visualize anything if you're having a hard time seeing it.